Section 11 of Gray's Anatomy, Part 1. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Morgan Scorpion. Anatomy of the Human Body, Part 1, by Henry Gray. Bone, Part 2. Chemical composition. Bone consists of an animal and an earthy part intimately combined together. The animal part may be obtained by immersing a bone for a considerable time in dilute mineral acid, after which process the bone comes out exactly the same shape as before, but perfectly flexible, so that a long bone, one of the ribs for example, can easily be tied in a knot. If now a transverse section is made, the same general arrangement of the Haversian canals, lamellae, lacunae, and canaliculi is seen. The earthy part may be separately obtained by calcination, by which the animal matter is completely burnt out. The bone will still retain its original form, but it will be white and brittle, will have lost about 1/3 of its original weight, and will crumble down with the slightest force. The earthy matter is composed chiefly of calcium phosphate, about 58% of the weight of the bone, calcium carbonate about 7%, calcium fluoride and magnesium phosphate from 1 to 2% each, and sodium chloride less than 1%. They confer on bone its hardness and rigidity, while the animal matter, ossein, determines its tenacity. Ossification. Some bones are preceded by membrane, such as those forming the roof and sides of the skull. Others, such as the bones of the limbs, are preceded by rods of cartilage. Hence two kinds of ossification are described, the intramembranous and the intracartilaginous. Intramembranous ossification. In the case of bones which are developed in membrane, no cartilaginous mould precedes the appearance of the bony tissue. The membrane which occupies the place of the future bone is of the nature of connective tissue, and ultimately forms the periosteum. It is composed of fibres and granular cells in a matrix. The peripheral portion is more fibrous, while in the interior the cells or osteoblasts predominate. The whole tissue is richly supplied with blood vessels. At the outset of the process of bone formation a little network of spicules is noticed radiating from the point or centre of ossification. These rays consist at their growing points of a network of fine clear fibres and granular corpuscles with an intervening ground substance. The fibres are termed osteogenic fibres, and are made up of fine fibrils differing little from those of white fibrous tissue. The membrane soon assumes a dark and granular appearance from the deposition of calcareous granules in the fibres and in the intervening matrix, and in the calcified material some of the granular corpuscles or osteoblasts are enclosed. By the fusion of the calcareous granules the tissue again assumes a more transparent appearance, but the fibres are no longer so distinctly seen. The involved osteoblasts from the corpuscles of the future bone, the spaces in which they are enclosed constituting the lacunae. The involved osteoblasts form the corpuscles of the future bone, the spaces in which they are enclosed constituting the lacunae. As the osteogenetic fibres grow out to the periphery they continue to calcify and give rise to fresh bone spicules. Thus a network of bone is formed, the meshes of which contain the blood vessels and a delicate connective tissue crowded with osteoblasts. The bony trabeculi thicken by the addition of fresh layers of bone formed by the osteoblasts on the surface, and the meshes are correspondingly encroached upon. Subsequently, successive layers of bony tissue are deposited under the periosteum and around the larger vascular channels which become the Haversian canals, so that the bone increases much in thickness. Intercartilaginous ossification. Just before ossification begins the mass is entirely cartilaginous, and in a long bone, which may be taken as an example, the process commences in the centre and proceeds towards the extremities, which for some time remain cartilaginous. Subsequently a similar process commences in one or more places in those extremities and gradually extends through them. The extremities do not, however, become joined to the body of the bone by bony tissue until growth has ceased. Between the body and either extremity a layer of cartilaginous tissue, termed the epiphyseal cartilage, persists for a definite period. The first step in the ossification of the cartilage is that the cartilage cells, at the point where ossification is commencing and which is termed a centre of ossification, enlarge and arrange themselves in rows. The matrix in which they are embedded increases in quantity, so that the cells become further separated from each other. A deposit of calcareous material now takes place in this matrix, between the rows of cells, so that they become separated from each other by longitudinal columns of calcified matrix, presenting a granular and opaque appearance. Here and there the matrix between two cells of the same row also become calcified, and transverse bars of calcified substance stretch from one calcareous column to another. Thus there are longitudinal groups of the cartilage cells enclosed in oblong cavities, the walls of which are formed of calcified matrix which cuts off all nutrition from the cells. The cells in consequence atrophy, leaving spaces called the primary areolae. At the same time that this process is going on in the centre of the solid bar of cartilage, certain changes are taking place on its surface. This is covered by a very vascular membrane, the perichondrium, entirely similar to the embryonic connective tissue already described as constituting the basis of membrane bone. On the inner surface of this, that is to say, on the surface in contact with the cartilage, are gathered the formative cells, the osteoblasts. By the agency of these cells a thin layer of bony tissue is formed between the perichondrium and the cartilage, by the intramembranous mode of ossification just described. There are then, in this first stage of ossification, two processes going on simultaneously in the centre of the cartilage, the formation of a number of oblong spaces, formed of calcified matrix and containing the withered cartilage cells, and on the surface of the cartilage the formation of a layer of true membrane bone. The second stage consists in the prolongation into the cartilage of processes of the deeper or osteogenetic layer of the perichondrium, which has now become periosteum. The processes consist of blood vessels and cells, osteoblasts or bone formers, and osteoclasts or bone destroyers. The latter are similar to the giant cells, myeloplaxes, found in marrow, and they excavate passages through the new formed bony layer by absorption, and pass through it into the calcified matrix. Wherever these processes come in contact with the calcified walls of the primary areolae, they absorb them, and thus cause a fusion of the original cavities and the formation of larger spaces, which are termed the secondary areolae or medullary spaces. These secondary spaces become filled with embryonic marrow, consisting of osteoblasts and vessels, derived, in the manner described above, from the osteogenetic layer of the periosteum. Thus far there has been traced the formation of enlarged spaces, secondary areolae, the perforated walls of which are still formed by calcified cartilage matrix, containing an embryonic marrow derived from the processes sent in from the osteogenetic layer of the periosteum, and consisting of blood vessels and osteoblasts. The walls of these secondary areolae are at this time of only inconsiderable thickness, but they become thickened by the deposition of layers of true bone on their surface. The process takes place in the following manner. Some of the osteoblasts of the embryonic marrow, after undergoing rapid division, arrange themselves as an epithelioid layer on the surface of the wall of the space. This layer of osteoblasts forms a bony stratum, and thus the wall of the space becomes gradually covered with a layer of true osseous substance, in which some of the bone-forming cells are included as bone corpuscles. The next stage in the process consists in the removal of these primary bone spicules by the osteoclasts. One of these giant cells may be found lying in a house ship's foveola at the free end of each spicule. The removal of the primary spicules go on pari passu with the formation of permanent bone by the periosteum, and in this way the medullary cavity of the body of the bone is formed. This series of changes has been gradually proceeding towards the end of the body of the bone, so that in the ossifying bone all the changes described above may be seen in different parts, from the true bone at the centre of the body to the hyaline cartilages at the extremities. While the ossification of the cartilaginous body is extending towards the articular ends, the cartilage immediately in advance of the osseous tissue continues to grow until the length of the adult bone is reached. During the period of growth the articular end, or epiphysis, remains for some time entirely cartilaginous. Then a bony centre appears, and initiates in it the process of intracartilaginous ossification, but this process never extends to any great distance. The epiphysis remains separated from the body by a narrow cartilaginous layer for a definite time. This layer ultimately ossifies. The distinction between body and epiphysis is obliterated, and the bone assumes its completed form and shape. The same remarks also apply to such processes of bone as are separately ossified, e.g. the trochanters of the femur. The bones therefore continue to grow until the body has acquired its full stature. They increase in length by ossification continuing to extend behind the epiphyseal cartilage, which goes on growing in advance of the ossifying process. They increase in circumference by deposition of new bone from the deeper layer of the periosteum, on their external surface, and at the same time an absorption takes place from within, by which the medullary cavities are increased. The permanent bone formed by the periosteum when first laid down is cancellous in structure. Later the osteoblasts contained in its spaces become arranged in the concentric layers characteristic of the Haversian systems, and are included as bone corpuscles. The number of ossific centres varies in different bones. In most of the short bones ossification commences at a single point near the centre, and proceeds towards the surface. In the long bones there is a central point of ossification for the body or diaphysis, and one or more for each extremity, the epiphysis. That for the body is the first to appear. The times of union of the epiphysis with the body vary inversely with the dates at which their ossifications begin, with the exception of the fibula, and regulate the direction of the nutrient arteries of the bones. Thus the nutrient arteries of the bones of the arm and forearm are directed towards the elbow, since the epiphyses at this joint become united to the bodies before those at the opposite extremities. In the lower limb, on the other hand, the nutrient arteries are directed away from the knee, that is, upwards in the femur, downward in the tibia and fibula, and in them it is observed that the upper epiphyses of the femur and the lower epiphyses of the tibia and fibula unite first with the bodies. Where there is only one epiphysis, the nutrient artery is directed towards the other end of the bone, as towards the acromial end of the clavicle, towards the distal ends of the metacarpal bone of the thumb and the metatarsal bone of the great toe, and towards the proximal ends of the other metacarpal and metatarsal bones. Parsons groups epiphyses under three headings, viz. 1. Pressure epiphysis, appearing at the articular ends of the bones and transmitting the weight of the body from bone to bone. 2. Traction epiphyses, associated with the insertion of muscles and originally sesamoid structures though not necessarily sesamoid bones. And 3. Atavistic epiphyses, representing parts of the skeleton which at one time formed separate bones, but which have lost their function, and only appear as separate ossifications in early life. End of section 11.